This is the first of a set of videos on the intermediate value theorem for Math 151. The point of these videos is to give you a thorough and self-paced covering of this material so that you can be well prepared for any homework or test problems that may arise from it. This first video is going to talk about what the intermediate value theorem is and highlight sort of where we're going to go in the next videos to how we use it. In order to discuss the intermediate value theorem, the first thing we have to talk about is continuity, because continuity is a fundamental part of this theorem and why it works. So in class, we've already learned the definition of what it means for a function to be continuous. So a function f is continuous at a point C if the limit as x goes to C of f is the same as the value at C. And in addition, we said that a function is continuous on an interval if it is continuous at each point of that interval. And so there's two main ways we can sort of intuit what this definition of continuity means. So the first is by looking at just what it means to be continuous. And the limit part sort of tells us what the function looks like it's trending towards as I approach C. So the limit is, okay, where is this function going as I approach C? And then the f of C part is the actual value of the function. So what the function is trending towards is equal to the actual value. And sort of how we can interpret this is that the function's going where it should be going. That is, if it's trending towards a point, that's the point it lands on at that value. If this is true over an entire interval, then that means sort of it's smoothly varying along as it goes. And the second way to interpret this, which is sort of what you probably thought of intuitively, that you can draw the graph of this function without picking up your pencil. And that sort of comes from this previous one. Right? If I'm drawing the graph with my pencil, and the function is trending towards a certain point, if the value is not there, then I have to jump somehow to get to the actual value. So as long as it's continuous, I can draw the graph in one smooth motion without actually having to pick up my pencil. And that's sort of where the IVT is going to come from. At least the intuition behind it is from this second fact here. So what is the IVT, intermediate value theorem, which I will abbreviate as IVT from here forward? So what is the statement? The statement says this: if f is a continuous function on an interval from A to B, then for every m between f of A and f of B, there is a point C in the interval AB so that f of C equals m. We'll talk about what all this means in a second, but the idea is if I'm starting at f of A and trying to go to f of B, I have to cross every value in between them because I can't jump, I can't go to infinity, I can't do anything weird. Since I'm continuous, I have to be able to draw a smooth graph connecting those 2 points, which is going to cross over every value in between f of A and f of B. And the picture you want to have in your mind when you're thinking about the IVT is this one here. So with this picture, we see that we are starting at f of A up on top, and we have to flow all the way down to f of B here at the bottom. And for every m that I want to draw in between there, I can find a point where I cross that level. Because the function is continuous, it has to cross every point in between, so I could find this point C where f of c equals m for the m that I've drawn in this picture. Note that it's important that our function was continuous for this to work. For instance, if I draw in purple here a graph that went like this, and then jumps down to here, and then goes like that, that graph does not cross the line f of c equals m, so there's no point between a and b where f of c equals m because I've jumped over that line. So if it's discontinuous, there's no way I can say anything about this. But if it's continuous, I know I will have a point inside where f of c equals m. So the important things we'll see going forward are that we need this continuity here. We need m between these 2 points, and then our c is in the interval that gives us our result. So, some comments now on the IVT and what it says and what it doesn't say, importantly. So, the IVT says there is a point C between A and B so that f of c equals m. There could be more than one. We have no way of knowing, but the theorem says there is at least one there somewhere. Right? If I go back to the picture here, if I had picked a different value of m, say one up here, that one has 3 values where f of c equals m. There's one here, there's one here, and there's one over here. So that one has 3. It still meets the theorem. The theorem says there is one. There is one. There's actually 3. So it says there's going to be one there somewhere. It does not say that there is exactly one. That would be a very different statement, but that's not the one that we have here. Second point about the IVT. It gives no method for actually finding the C. Right? It says it's there somewhere, but it doesn't say much about how to get there or what to do with it. We'll do a little bit of this in the 4th video here. But the statement as is gives us nothing towards how to actually find that C. And then last point, the theorem says nothing if m is not between f of a and f of b, or if f is not continuous. If we don't have both m between f of a and f of b and f continuous, the theorem just is quiet. The theorem says nothing. It says nothing about whether there is or isn't points that meet this condition. It just says nothing. So it could be true, there could be values, or there could not be values, but the theorem doesn't say anything about that. So I go back to the picture again. If I had picked an m value that was really high up top, say way up here, then I get a point where it crosses the purple function. So even though that purple function is discontinuous, it still satisfies the conclusion of the intermediate value theorem, which is fine. The theorem did not say there had to be a point, but there happened to be one, and that's okay. The same holds true for m values outside the range in f of a and f of b. There might be values, there might not be. The theorem just is quiet and says nothing about that. So there's our comments again. Now, how do we use this? Well, there's 3 main ways that this theorem gets used sort of across the board here, and that's what the next 3 videos we'll talk about. So the next video we'll talk about finding roots of functions, i.e. finding values where the function is 0. One after that, we'll talk about finding solutions to equations, and then we'll talk about the bisection method. This method gives us a way to sort of figure out where this solution happens to be using a couple different methods or a couple different approaches to it. But we'll get there at the end. It's not really the main point of the intermediate value theorem. It's sort of a consequence of it. So next videos we'll go through all these and show you examples of problems that may come up on homeworks or on exams that use the IVT to do different things. Those will be in the next 3 videos.